Random Play Dance, or RPD, is an event where dancers stand in a circle and short K-pop chorus clips play one after another with a countdown between each one. Whoever knows the dance jumps in. Today, organizers stitch these rounds together by hand in audio editors, picking choruses, normalizing volume, inserting countdowns, exporting a single file. It takes hours per event. RPD Round Builder is a web app that turns your library of chorus clips into a fully timed round in about 30 seconds. Now, let's dive into the demo of the app with my RPD's signature slogan, Music Cue. First, I'll upload a few tracks. The app parses the file name for artist-song and creates draft entries. I trim each clip to just the chorus, tag it, and approve it into the library. On the round setup page, I pick a target duration, let's say 6 minutes, choose a countdown asset, and optionally narrow the pool. I can either let it use every ready song or check specific tracks. Hit Create Round, and the app sequences the chorus clips with countdowns between them, ready to preview. I can edit either as a list, drag, trim, set fades, set gain and decibels, or open the full timeline editor and edit waveforms directly, like Audition. When I'm happy, I hit Export. The backend renders a single MP3 with FFmpeg and gives me a download. If I'm planning a 3-round event, I can do it in one shot. I switch to custom selection, pick 50 songs, set rounds to 3, and generate 3 rounds. The server seed shuffles the pool once, then partitions it, so every song plays in exactly 1 round. The batch generator is a single deterministic function. Given a seed, the same pool always produces the same 3 rounds. It costs each song as clip duration plus countdown duration, fills the current bucket up to the target, then advances. The last bucket absorbs overflow, so the invariant every pool song appears once always holds, even if the pool is larger than n times target. Round generation never talks to FFmpeg directly. It produces a render manifest, a fully resolved description of every segment with absolute offsets, fades, gains, and resolved countdown gain, override, or asset default. The manifest is what the preview player schedules in the browser, what the FFmpeg pipeline renders on the server, and what the validation script checks the artifact against. One source of truth for 3 consumers. Every payload between front-end, back-end, and database goes through a ZOD schema in the shared package. When I added per-clip gain, the schema change forced compile errors in 5 places that needed updating. That kept the migration honest end-to-end. I built this in Cursor with Claude as the coding agent. The loop that worked was switch to plan mode, have the agent walk the codebase, then write a markdown plan with explicit edits, file paths, and tests. Only after I approved the plan did it switch into agent mode and execute. Each task ended with TSC, Vitest, and a PSQL constraint check, so regressions surfaced inside the same loop instead of 2 days later. What worked best was forcing it to plan first. Early in the project, I let it implement straight from a prompt, and it made architectural calls I didn't agree with. The wrong place to put state, the wrong service boundary. Plan mode let me push back on the design before any code was written. What I had to watch for was confident wrong assumptions about libraries and SQL. Asking it to verify with the actual repo, read the migration, run the query, paste the output, caught those before they shipped. RPD Round Builder takes a job that used to be a slow afternoon in an audio editor and turns it into a 30-second click-through with a real timeline editor when you do want to fine-tune. Thanks for watching.